Today we're starting 11.1, which is polynomial terminology. So let's get started with vocabulary review. First thing we need to know is the word term. And term is a number, variable, or the product of a number and or variable. For example, 5x squared, that's a term. If I have 4xy, that's a term. What about 16? That's also a term. So any one of these by themselves are called a term. Next vocab word is coefficient. A coefficient is the number factor of a term. So what's the coefficient of 5x squared? It's 5. The coefficient of 4x squared is 4. And then 16 actually has a different name because when we have a term that contains only a number, that is called a constant. So 16 is actually a constant term. So that's our vocabulary. We should already know that, but if not, then here's a refresher. So now a polynomial is a single term or the sum of two or more terms with whole number powers. Real quick, what does whole numbers mean? Whole numbers are positive, and also they are not fractions, so no fraction and no decimal. That's what has to be true about these powers for it to be a polynomial. Oops. So let's look at a couple examples. We want to tell whether each expression is a polynomial. If the answer is no, then we are going to explain why. So number 1, it says 3x to the negative 2 minus 5. Well, what has to be true about a polynomial? It is a single term or the sum of two or more terms with whole number powers. Do these have whole number powers? Well, x to the negative 2 does not. X to the negative 2 is not a whole number because it is not positive. So the answer to this is no, because there's a negative exponent. Next one, number 2, we have 6x plus 4x squared. I see x to the first power, that's a whole number power. X squared is a whole number power. So yes, that is a polynomial. Number 3, 15. I don't see an exponent at all. But we know that 15, this is the same as having 15 times x to the 0. Because what does x to the 0 equal? X to the 0 equals 1. So 15 times 1 is just 15. So actually, yes, just having a constant is a polynomial. Let's look at number 4. 2 plus x to the 1/2. Well, 2, we know that has x to the 0, and that's a whole number power. But x to the 1/2, is that whole? No, because remember, whole numbers can't be fractions. So the answer is no, because there is a fractional exponent. Number 5, we have 3x over x cubed. Well, just looking at it, it does look like we have whole number powers. But x to the 3rd, because that's on the bottom, that actually means we have a negative exponent. This can be rewritten as 3x times x to the negative 3rd. Remember, a positive exponent on the bottom, if it's brought to the top, it becomes negative. So this one is not a polynomial. The answer is no. X on the bottom means negative exponent. We can't have a negative exponent if it's a polynomial. All right, the next term that we're going to look at is called the degree. So if we are looking at the degree of a term, it is the sum of the exponents of the variables contained in that term. So notice this is just the degree of a term. Later we'll talk about the degree of an entire polynomial. So let's find the degrees of these terms. Here's our term 4x to the 5th. Well, the degree is the sum of the exponents of the variables in this term. There's only one exponent, and it is 5. So on this one we have x to the 5th. So our degree is just 5. Comes from that 5th power. On the next one, we have x squared. Well, I only have one exponent, so my degree is that exponent, which is 2. 42x squared y squared. When we have multiple exponents, what do we do with them? We take their sum. That means we add them. So the 2 plus 3 gives us a degree of 5. We just have 6. Remember what we talked about up here. If I just have a constant, that's the same as having 6 times x to the 0. So that means my degree is 0. Then on this one, again, we have two variables. So what do we do with their exponents? We add them. This is a cubed. This is b to the first. So that means we have 3 plus 1. That gives us a degree of 4. So this is just the degree of the term. So let's look at a polynomial here, excuse me, and we are going to identify the degree of each term in the polynomial. So here it is, 2x cubed y minus 6x squared y squared plus 9xy minus 13x plus 15. Go ahead and write that down. We want to find the degree of each of the terms. So let's look at this first term. Remember, to find the degree of just a term, we take the exponents and we add them. So this is x cubed, that's y to the first. So the 3 plus 1 gives me degree 4. Next term, I see x squared, y squared. The 2 plus 2 gives me degree 4. 9xy. This is x to the first, y to the first. So the 1 plus 1 gives me a degree of 2. Then we have 13x. That x has a degree of 1, an exponent of 1, which gives me a degree 1. And 15, we know that's the same as 15 times x to the 0, so we have a degree of 0. And let's look at this note over here real quick. All non-zero constant terms have a degree of 0. So that's just like this. 6 has a degree of 0. 15 has a degree of 0. But the constant 0 does not have a degree. So if we had x squared plus 0, 0 does not have a degree because we don't even have to write that 0. That's the same as just having x squared. So 0 does not have a degree. All right, we're on the back of the notes now. We are going to look at the degree of a polynomial. So the degree of a polynomial is the greatest degree of any term in the polynomial. So here we have polynomials. What we have to do to find the degree of the entire polynomial is find the degree of each piece and then just take the greatest one. So let's look at this. We know that the degree of 2x squared y, this is a y to the first, so we add the 2 plus 1 and that's degree 3. The degree of 3x squared, we just have the x squared, so that degree is 2. The degree of 7, remember degree of a constant term, is 0. So I have degree 3, degree 2, degree 0. What's the greatest degree? It's 3. So the degree of this entire polynomial is 3. Next one, negative 5y cubed. The degree of that is 3. Degree of 4y squared is 2. Degree of negative 8y is 1. Degree of negative 3 is 0. So we need to find the greatest degree. That one is 3. So the degree of that polynomial is also 3. And last one. We have 36. That's a constant term, so the degree is 0. 12x, that x has an exponent of 1, so it's degree 1. X squared, the exponent is 2, so degree 2. Well, what's the greatest degree? It's 2. So the degree of that entire polynomial is 2. All right, the standard form of a polynomial is a polynomial whose terms are written in decreasing order of degree. And that's the important part, because a lot of us have seen standard form as being alphabetical order. You put the x's first and then the y's, and there is something valuable about that. But the first thing that we will have to look at here is the degree. And we'll see examples with x's and y's in a few minutes. Other vocabulary word, and then we will label this polynomial, is the leading coefficient is the coefficient of a polynomial's leading term when it is in standard form. So let's look at this polynomial here. We have 9x to the 5th plus 4x squared minus 5. Well, first of all, each of these are called terms. Those are the terms of our polynomial. What we looked at on the front of our page was that this term here, the one at the end that doesn't have an x, is called the constant. Now, of course, we do know that we can write that as 5x to the 0. Well, what do these tell us over here? This tells us that the leading coefficient is the coefficient of the leading term. This is the leading term. That means 9 is the leading coefficient. And then lastly, this x to the 5th here, this is going to be the degree of the polynomial. The degree of the polynomial, because when we put them in standard form, the one that goes in the front will be the one with the greatest degree, because we write them in order of decreasing degree. That means we put biggest degree and then the next biggest and so on and so on. So we're going to look at some examples of this. For the next few examples, we want to put the polynomials in standard form. So first thing we need to do is know what their degrees are so we can put the biggest degree first. Well, 4x has a degree of 1, negative 9 has a degree of 0, and then 2x squared excuse me, has a degree of 2 because of that x squared. So we've got to put the one with the greatest degree first, and that is the 2. So we put 2x squared first. Done with that one. Now we need to take the one with the next biggest degree, and that's 1. So now we have a positive 4x next. And then the negative 9 has the lowest degree, so it comes at the end. So now our polynomial is in standard form. Next one. This one I see y and x xy. So let's look at this. We have a degree here of 2. Then x squared has a degree of 2. And 6xy, that's x to the first, y to the first, we add them, degree 2. So these actually all have the same degree. If they all have the same degree, then we are going to revert to alphabetical order. That means x's come first, so the x squared. Then we have this term that has an x and a y, so that would come next. And then at the end we would put the y's. So first thing we always think about is biggest degree, and then after that, if they have the same degree, then we go to alphabetical order like this one, x squared, and then the x and the y, and then the y squared. Okay? Last one, let's look at these degrees. 18x squared y, we know this has a degree of 3 because that y has a 1. Negative 7x to the 4th, that's degree 4. 15xy squared, that one also has a degree of 3. And negative 11, of course, has a degree of 0. So clearly, first thing we have to do is put that degree 4 first. Negative 7x to the 4th goes first. Next, we have 2 degree 3s. So that means we need to go to alphabetical order, and that is looking at which one has more x's. This has x squared y, and then this just has x, y squared. So we are going to put first the 18x squared y because it has more of the x's. Now we have 15xy squared because it also has degree 3. And then, of course, we put that constant term, the negative 11, at the end.